So to be here. I want to talk to you guys today about modular blockchains, and I believe that we're entering the dawn of a new era of blockchain architecture that's driven by modularity. So we're going to try to get through a lot of stuff really quick. So you might be wondering, what are modular blockchains? So just to start with, the previous era of blockchains, Bitcoin, Ethereum, Solana, most of the L1 chains that we know today are built in a monolithic way, meaning that all of the functions happen within one protocol and within one set of nodes. And the modular paradigm is a way to split up those functions into separate layers and separate protocols that then can be recombined and specialized for a specific use case to achieve better scalability and more flexibility. So one way to think about this is an evolution of blockchain architectures. We started with Bitcoin. You can think of Bitcoin as sort of like a calculator. It had a very specific and limited functionality where you could send and receive Bitcoins, and that was pretty much it. It really didn't have much programmability or expressivity. Then we had Ethereum come along, and Ethereum kind of generalized blockchains to be more like a computer. And as we all know, computers are very flexible and programmable. So with Ethereum, you could do a lot more things and build a lot more applications than you could on Bitcoin. And then finally, the next evolution of blockchains are the modular blockchain architectures, which is introduced by Celestia. And you can think of this as, again, another evolution to something more similar to cloud computing. And I'll explain a little bit more why I believe that analogy. And so here's kind of a more graphical way to see this, is that we started with Bitcoin in 2008, Ethereum in 2013, and now, since 2019, with the publishing of the Lazy Ledger white paper, we're entering a new modular era. So let's talk a little bit about what makes modular blockchains, what the advantages are. So first of all, modular blockchains have a very specific new feature, which is that for the first time, the more nodes there are in the network, the bigger the blocks can be. So that means you're no longer stuck with one fixed block size, and the block size can increase to accommodate more transactions. So whereas in a monolithic world, you have a fixed block size, and as the number of users increases and the amount of demand increases, then the price to use the blockchain also has to increase. In a modular blockchain, you can actually increase the block size and keep the fees consistent and stable, even as more and more people want to use the network. The second major advantage of modular blockchains is that they're more flexible. So because you separate out the execution from the base L1 layer of consensus and data availability, you're not stuck with one single virtual machine like the EVM or the Solana VM. So you can actually, as a developer, choose what virtual machine or execution environment you want to build with. And this enables you to customize your application and build something that is better and more tailored to your use case. And another aspect of modular blockchains is that they enable shared security. So people who want to deploy a new blockchain, rather than having to issue a new token, bootstrap an entirely new validator set, and their own security from scratch, they can inherit it from a shared data availability layer like Celestia. And so this really rapidly accelerates the speed at which people can deploy new blockchains. And shared security also enables these rollups to be able to interoperate securely, whereas in a monolithic ecosystem, chains that want to interoperate and connect with each other have to make a trust assumption on the counterparty chain. And this is not secure because the chain could be not actually trustworthy, essentially. And so how does this work? Well, under the hood, modular blockchains are powered by two core technologies, which I'll explain. One is something that we're all very familiar with, which are rollups. And the other is something that Celestia specializes in, which is called data availability sampling. So in a monolithic architecture, as you can see on the left, when you want to run a node to verify the chain, you have to download every single transaction. So you have to download the entirety of the block data, And then you have to re-execute every single transaction in that block. And so you can see that in this model, this monolithic model, if you increase the number of transactions, then every node, every participant in the network has to do more work. They have to download more data and re-execute more transactions with an increase in the block size. And so the problem with that is that nodes have a finite amount of bandwidth to download things and a finite amount of computation power to verify transactions. So that's what results in this fixed and finite block size for monolithic chains and makes them not scalable inherently. Now, in a modular architecture, you have a different way of verifying chains and running nodes. And instead of having to download every single transaction and re-verify it, you can just download a very small sample of data, a few kilobytes of data, and then you can verify a single proof that the transactions were executed correctly. So you no longer have to re-execute every transaction, you no longer have to download every single transaction. So now when the number of transactions increases, the amount of work for the nodes to verify it does not increase. And so specifically I want to talk a little bit about data availability sampling. So the way that it works under the hood is that you have to construct your block data in a new way, and you use something called erasure coding, which I'll explain. And when you construct the block in this new way and you expand it using erasure coding, nodes can sample randomly among the data, and each time they sample successfully, they get an increased confidence that the entirety of the block was published. And this is something that we, like erasure coding, which is the underlying technology that enables data availability sampling, is actually used throughout different parts of technology like CD-ROMs and even QR codes. So you can actually try this out and see that even this QR code on the right, even though it's partially obstructed, you can still actually use it. So it's the same way in Celestia, where someone tries to hide block data, they have to hide a really significant amount to render the entire block unavailable. And I want to make something really clear to people, which is that data availability is very different to data storage. And a lot of people get this mixed up, and that's partly why we think that a better word might be data publication rather than data availability. So data storage is sort of like, I use an analogy, like a food analogy, which is like, data storage is more like canning food and like storing it away in a warehouse. And data availability or data publishing is more like having an all-you-can-eat buffet. So the difference is in data storage, you want to ensure that you can have access to data later. Later on down the road, let's say a year later, you want to be able to still access and retrieve this data. In data availability or data publishing, you want to verify that the data was published and made available for anyone to download. So you want to verify that someone served it out on a buffet to anyone who wanted to sample it or taste it. So there's very different functions. And last but not least, the modular architecture enables a new kind of node, which I was alluding to, called a light node, where it can be run on a consumer device like a phone. And this is really powerful because for the first time it will enable people to verify the blockchain directly on their phone. So users are no longer having to rely on an RPC service or some centralized system to verify the chain on their behalf. They're able to verify and interact with the blockchain directly. And this is what leads to this positive network effect, which is that as more users join the network, then more block space becomes available, because by running light nodes, they're increasing the scale of the network. And that creates more capacity to run more apps, which then attracts more users, and the cycle repeats. So unlike in monolithic blockchains like Ethereum, where as more users join, the more expensive it becomes, so you have this negative network effect, Celestia has, and modular blockchains have this positive network effect. And so to summarize, the advantages of modular blockchains are you have increased scalability, you have better shared security and the ability to launch chains very easily, and you also have sovereignty or customizability, which is that developers can choose what kind of execution environment to run their applications within. So now returning to this cloud analogy that I alluded to earlier, we think that modular blockchains are very similar to the Web 2 cloud architecture, but for Web 3. So in Web 2, you have a data center like AWS, which provides very scalable compute for developers to come and run virtual machines, virtual servers, to host their applications and customize those servers. In the Web 3 stack, you have, instead of a data center, you have a data network like Celestia, which provides very scalable block space, and developers can come to run a custom virtual blockchain as a rollup and run their application that way. So it's very, very analogous. And my last slide is, sort of sums up the difference between the monolithic and modular approach, which is, in a monolithic approach, it's siloed. You silo innovation, you silo security into separate ecosystems that have to fight with each other for dominance. And this leads to maximalism and leads to just like inefficient, kind of redundant work, ever reinventing the wheel and fighting each other. And in the modular approach, it's an open, collaborative ecosystem where we can share innovation, we can share security, and everyone can win. So we really are excited about ushering in this new era for blockchain architecture, and we're launching our mainnet in a couple of months, and we hope to unleash a whole wave of innovation in the modular stack. So thank you very much.